Hello, I am Folisha Olaniyan. I'll be representing my group in the presentation of our project on fertilizers. In this presentation, I'll walk you through the background information on fertilizers, the types and composition, the nutrient use efficiency. We'll talk about the global impact of the advancement in the production of fertilizers. We'll talk about the advantage and the detrimental effect of it, and we'll end it with a little bit of conclusion. So, getting started, we'll talk about the introduction. Fertilizers are vital for global food security and modern agricultural practices. They enhance plant growth and agricultural production by supplying essential nutrients to soil and plants. Nitrogen, phosphorus, and potassium are key nutrients required for plant development and optimal function. There are two types of fertilizers. There are the organic fertilizers and the synthetic fertilizers. Each has its pros and cons, and their selection depends on factors such as soil type, crop variety, and nutrient needs. They also have environmental effects, which we will talk in depth as we move forward in this presentation. So now we'll talk about types and composition of fertilizers. Like I mentioned earlier, there are two types of fertilizers. We have the organic and inorganic fertilizers. So let's talk about the organic fertilizers. The organic fertilizers are derived from natural sources such as animal manure, compost, and plant growth. They gradually release essential nutrients, fostering sustainable plant growth. They improve soil structure and contribute to long-term soil health. Inorganic fertilizers are also known as synthetic fertilizers. They deliver vital nutrients like nitrogen, phosphorus, and potassium quickly into the soil, and they are essential for robust plant growth and development. Each fertilizer possesses a unique composition that addresses specific nutrient deficiencies in crops. Nitrogen rich fertilizers stimulate lush foliage growth, ideal for leafy vegetables. Phosphorus rich fertilizers bolster root development, particularly beneficial for root crops. Potassium rich fertilizers enhance overall plant strength, disease resistance, and stress tolerance. The strategic application of fertilizers transforms crop outcomes by aligning soil attributes and crop needs. Driving yields achieved through optimal fertilization contributes significantly to global food security, as we've mentioned earlier. Empowering farmers with knowledge about fertilizer types and their application is a key step toward a secure and sustainable food future. Now, let's talk about the nutrient use efficiency. Enhancing nutrient use efficiency for sustainable agriculture. Enhanced nutrient use efficiency revolutionizes fertilizer application for sustainable agriculture. Addressing the environmental impact of fertilizer use is a pivotal challenge in modern agriculture. This subtopic explores the transformative implications of nutrient use efficiency in terms of mitigating nutrient pollution, conserving resources, and promoting sustainable agriculture. Now, let's talk about mitigating. Okay, gas emissions. Right, good. Minimizing nutrient runoff and leaching. Nutrient use efficiency enhanced fertilizers offer gradual nutrient release, targeting precise plant needs. Excess nutrients like nitrogen and phosphorus often lead to runoff and water contamination. This proactive approach to nutrient management has unseen yet profound effects on environmental preservation. Sustaining soil health with nutrient use efficiency. Excessive fertilizer application disrupts soil nutrient balance, impacting microbial activity and soil health. Nutrient use efficiency enhanced fertilizers provide nutrients in a targeted and efficient manner by sustaining soil fertility and microbial activity. This preservation supports agricultural productivity and ensures farmland viability for generations. Mitigating greenhouse gas emissions. This is another important aspect of nutrient use efficiency. So, beyond soil and water, fertilizer production and application contribute to greenhouse gas emissions. Nutrient use efficiency technologies optimize nutrient utilization, potentially reducing excessive fertilizer use. This reduction minimizes greenhouse gas emissions like nitrous oxide, a significant contributor to climate change. Nutrient use efficiency indirect impact on greenhouse gas reduction extends its influence beyond agricultural immediate scope. Nutrient use efficiency revolutionizes fertilizer application to sustainable agriculture. Its multifaceted benefits include minimizing runoff, sustaining soil health, and reducing greenhouse gas emissions. By adopting NUE technologies, farmers contribute to a greener, more resilient agricultural ecosystem. This holds potential to reshape agricultural practices for a brighter and more sustainable future. Going back, so now we'll talk about the global impact of agriculture of fertilizers. Sorry for that notification. So now we'll talk about the scientific advancement of fertilizers. Fertilizers have improved from before to now, and these are some of the improvements that have been made. Tailored nutrient ratios. Researchers have fine-tuned the ratios of nitrogen, phosphorus, and potassium in fertilizers. These ratios consider the nuanced interplay of nutrients for optimal plant growth. Also, customized NPK ratios align with specific crop and soil requirements, enhancing plant uptake efficiency. This advancement optimizes nutrient availability and contributes to sustainable agriculture. We talk about slow release mechanisms. Slow release mechanism fertilizers are integrated with mechanisms for gradual nutrient release. Nutrient availability aligns with plant demand, reducing nutrient leaching into water bodies. This technology improves nutrient use efficiency and minimizes environmental pollution. Slow release fertilizers contribute to both economic benefits and long-term soil health. Enhanced nutrient uptake. Fertilizer formulations include compounds that enhance nutrient solubility and modify soil pH. These compounds facilitate nutrient absorption by plant roots even in suboptimal soil conditions. Nutrient availability is improved, leading to amplified crop yields and reduced fertilizer requirements. Enhanced nutrient uptake contributes to sustainable agriculture and resource optimization. Now, let's talk about the positive global impact of the scientific advancement of the use of fertilizers. Positive global impact. Number one, enhanced environmental preservation. Advancements in formulations reduce nutrient runoff, preserving water quality and aquatic ecosystems. Controlled nutrient releases Controlled nutrient release minimizes the risk of water contamination, thereby benefiting the environment. Another advantage is reduced greenhouse gas emissions. Precision application and optimized formulation decrease synthetic nitrogen fertilizer use. This mitigates nitrous oxide emission, which is a major climate change mitigation, like I mentioned earlier. Also, another advantage is resource efficiency. Precision agriculture minimizes excess fertilizer application, thereby conserving water, energy, and cost. Improved soil health and biodiversity. Enhanced nutrient delivery supports soil microbes, thereby enhancing soil structure and fertility. Sustainable practices like no-till farming are promoted. This fosters soil health and biodiversity. These are some of the positive global impacts of the scientific advancement of fertilizers. Now, let's talk about the detrimental global impact of this advancement. Soil microbiome disruption. Unregulated fertilization can disturb the intricate soil microbiome network. This can result in soil pH changes, which cause reduced microbial activity and soil structure degeneration. We also have groundwater contamination, and this means fertilizers' hidden impact extends to groundwater as excess nutrients infiltrate it, leading to compromised drinking water quality and ecologically disruptions in the water system. Soil degradation and health impacts. This is another detrimental effect of fertilizers because uncontrolled fertilizer use disrupts soil nutrient balance, leading to soil degradation, also affecting microbial communities, thereby impacting soil health and long-term agricultural productivity. Other possible detriment effects are nutrient runoff and water pollution, contaminant concerns. These advanced fertilizers can contain contaminants or residues, posing health risks to consumers. Unregulated use might lead to harmful substance in our water and soil. These are just few of the detrimental impact of fertilizers. Now, give a conclusion. Fertilizers exert an influence beyond the visible realm. They affect water bodies, groundwater, and soil. Thereby, we need to understand that these unforeseen effects can be very dangerous, and a balanced agricultural practice and environmental well-being is necessary. With this, we come to the end of our presentation. Thank you for your time and your attention.